All right, this is the final video for remote learning, the very last thing you guys are learning for this school year. So exciting. And it's going to be very similar to something we've already done, which is graphing linear inequalities. This chapter we've been doing systems. So what happens when you have two linear inequalities and I'm asking you to graph it on the same coordinate plane? So the first thing we're going to do is graph the first inequality. So y is less than 2x plus 4. First, we need to plot the y-intercept and then apply the slope. Now, remember, if we have a less than or greater than sign, we need to use a dashed line. So I'm going to connect those with mine's dotted, but dotted or dashed. Now we need to then shade, all right? So the two things for inequalities that are different from regular lines is dotted versus solid line, and then there's shading. So I always like to test 0, 0. So if we plug in 0 for x and 0 for y and simplify, we get the statement 0 is less than 4, which is true. So that means we're going to shade the side 0, 0 is on. We're going to repeat this exact same process with the second linear inequality that's there, and we're just going to graph it right on top of what we already have. So again, this is a great topic to have colored pencils or two different colors for. So plot the y-intercept, positive 1. The slope is also 1, so rise 1, run 1. And this time we have a greater than or equal to sign. So we're going to connect these with a solid line. Now for the shading, we'll test 0, 0 again, and then simplify. So we end up getting 0 is greater than or equal to 1, which is false. So that means we need to shade the opposite side that 0, 0 is on. So before we finish, the only thing left to do is just denote where the solution area is. For systems of inequalities, the solution is where the shaded areas intersect each other. So where we have purple shading on top of orange shading. And in order for me to see what this is, we're going to put a big capital S in that solution area. So any of these points are solutions to that system of inequalities. Let's do another example. So this time both of our equations are in standard form, so I'm going to graph this first one using an intercept table, plugging in 0 for x and plugging in 0 for y. We get the intercepts 0, -1, and -1, 0. We can plot those and connect them with a solid line because the inequality is less than or equal to. Let's test 0, 0 for shading. So we get 0 is less than or equal to -1, which is false, so we're shading the side 0, 0 is not on. Repeat the process for our second inequality. So once again, it's in standard form. I like the intercept table method, plugging in 0 for x and 0 for y. We get +3 and -3. So because of the inequality sign, once again, we'll connect with a solid line. Let's test 0, 0 for shading. So we get 0 is greater than or equal to 3, which is false. So we shade the opposite side. So the side 0, 0 is not on. So that would be above the line. Now notice our shaded areas don't intersect. So this is a perfect example of no solution. If the shaded areas do not intersect, then there's no answer. There is no ordered pair that will make both of them true. All right, our next one, our first inequality is in standard form, so I'm going to use an intercept table, plugging in 0 for x, solve for y and get -2. Plugging in 0 for y, I get 4 for x. Go ahead and plot those 2 points. We're going to connect with a dashed line because of the inequality sign and test 0, 0 for true or false. We get a false statement, so we do not shade the side 0, 0 is on, we shade the opposite side. Our second line is a vertical line. Just x and a constant on the other side is vertical, but it is also going to be solid because of the inequality sign. We still need to test for shading, so once again, we can test 0, 0. Now there's nowhere to plug in 0 for y, that's okay, just plug in 0 for x. Another false statement, so we can't shade where 0, 0 is, we shade the opposite side. So it's clear where the solution area is, where the two colors overlap. Put a little S there. I like to make mine fancy with the little lines on the end, but do whatever you want, because that's your business. All right, next example, -3x plus y is less than 3, standard form. Let's do an intercept table. Plugging in 0 for x and 0 for y, we get the points 0, 3 and -1, 0. We're going to connect with a dashed line because of the inequality sign and test 0, 0 for true or false. We end up with a true statement, so the side 0, 0 is on, or the origin, gets shaded. Next line, also in standard form. Plugging in 0 for x, I get -1 for y. Plugging in 0 for y, I get -1 for x. That one we didn't have to solve anything, so plot those 2 points. And connect with a dashed line because of the inequality sign. Let's test 0, 0 for shading. We get a false statement. So we do not shade where 0, 0 is, we shade the opposite side. And I can see that that bottom middle section is where the shading overlaps, so that's where I'm going to put my fancy S. You have 2 U-tries, so complete those and send photos to me to my email, and this will be the last set of video notes for remote learning. Thank you guys for listening.